Hey everyone, welcome to another JavaScript lesson in Hatch. Today, we are going to learn to code a 3D mole match game. The way this game works is we have a mole object that can move randomly over the top of any of these boxes. And we have to hit the mole by clicking on it when it's on top of these boxes. So when you click on the mole, there is a sound effect that plays and the score increases. So we will learn how to code all of these functionalities. So let's get started. First of all, I'm going to open up the template link project. Now, as you can see, the template link already contains the design of the game, but it doesn't contain any code here. So we will learn to write the code, but before we start writing the code, we are going to understand how the game was designed. So once you have opened up the template project, let's understand the design of the game. So if you look at the left panel here, you will see that this game contains a lot of objects. First of all, there's the player and the camera that's going to represent you in the game. And then we have a light that makes all the other objects visible in the game. Along with that, there is a ground object. Now this is the gray ground box that you're seeing here, on top of which you can see everything else is placed. Now then, we have an object called Diglett. So this is our mole object. This is a Pokemon called Diglett that we are using as our mole object. And we are going to move this Diglett on top of these boxes in our code. Now along with that, we have a gradient sky object that makes this background sky, and we have a scoreboard that shows this 3D text called score:0. So we are going to use the scoreboard to display our score. And then you will notice that this game contains a lot of boxes. Box 2, box 3, box 4, and so on till box 25. So we have these 25 boxes that are laid down in a grid of 5 rows and 5 columns. We are going to move our mole on top of any of these boxes. So to move the mole randomly over the top of these boxes, what we are going to do is we are going to be changing the X and the Z position of this mole object randomly to the X and Z position of one of these boxes, and that is how our mole is going to appear over any one of these boxes. And then you will notice that in the design tab here on the left side, there is a sound object called click effect. We are going to use this sound object to play the sound when you have hit the mole successfully. So now let's understand how the mole is going to move over these boxes. So let's look at the position of these boxes. Let me click on the very first box here, and that's the box object. Now if you look at the position, you will see that this box has the position -6 in X, 0.05 in Y, and then 0 in Z. And we know that if we move in the left and right direction, then that should not be changing the Z position of these boxes. So if you see, we have our box object. Now if you click on the box on the left or right of it, you will notice that only the X position of this box is different from the X position of this first box. So the second box here, called box 2, has the X position as -3. And the Y and the Z position are the same as that of the first box here. See, the Y position of this first box is 0.05 and the Z position is 0. And same goes for the second box called box 2. The Y position here is also 0.05 and the Z position is 0. And you will notice that for the remaining 3 boxes as well, for this box as well, you see, only the X position has changed to 0 and the Y and the Z position have stayed the same. So now you notice what's happening here. Let's look at these first 5 boxes. See, if you want to move this mole over this box, right? Then what do we have to do? We just have to set the X position and the Z position of the mole to the X position and the Z position of this first box. So this first box has the x and z position of -6 and 0. So let's do that. Let's click on the mole here and let's set the x position of this mole to -6 and the z position to 0. And now you see the mole is on top of the first box. Now if we want the mole to move over the second box or the third box or the fourth box or the fifth box, then all I have to do is change the x and z position to match the x and z position of these boxes. Yep. So if I, let's say, set the x position of my mole to 6, then it's going to the very last box here. See? So because the last box's x position is 6 and the z position is 0. So that's what we did here. Now, if we want to move the mole behind, what do we need to do? We need to change the z position, right? So if you look at every single of these rows, right? Let's look at these next 5 boxes here. For all of these 5 boxes, if you look at the x and the z position, for all 5 of these boxes, the z position stays as -3. And if you move left or right, the x position is either -6 or -3 or 0 or 3 or 6. So see, what's happening is all of these boxes are just 3 units apart from each other, either in the x direction or in the z direction. And in the x direction, the x position of all of these boxes are either -6, -3, 0, 3 or 6, and the z position of all of these boxes is either 0 or -3 or -6 or -9 or -12. That's because as you go farther behind, the z position keeps on decreasing and the very first row here has the z position of 0. So let me open up my whiteboard and show you what I'm talking about. So what I'm saying is, the x position of all of these boxes, it's either -6, -3, 0, 3 or 6. And the z position of all of these boxes, it's either 0, -3, -6, -9 or -12. So if we are able to code and tell our computer to set the x position of our mole to any one of these values, right, in the x position, and to set the z position of the mole to any one of these values, then we will be able to move the mole over the top of any of the 25 boxes that we are seeing in our game. So let's do that. Let me go back to my game here, and I am going to go to the code window, and we are going to tell our computer to first of all generate a random position and then move the mole object to that random position. Now you see, actually I moved my mole to the right side, so let me go back to the design tab and let me set the z position and the x position of this mole back to 0 and 0 for the beginning. And now I can go back to my code window and start coding. So let's start by learning how can we generate random numbers. I'm going to create a variable and give it a name a. And then I'm going to type this function called math.random. Math.random followed by a pair of round brackets and ended with a semicolon. So math.random is a JavaScript function that tells your computer to generate a random number that is between 0 and 1. And when I say let a is equal to math.random, our computer will generate a random number between 0 and 1 and assign that number to the variable a. So now if you tell your computer to print out the value of the variable a using the hatch.log function, so if I type hatch.log followed by a pair of round brackets, and inside the round brackets I write the variable a. Now if you run the script, you will see that the variable a gets assigned a random value. It says 0.1826. See, it's a random number between 0 and 1 that was assigned to the variable a. Let me actually show you this way. If I add a timer in my code here, and inside the timer, I tell my computer that every 1 second, give the variable a new random value. A is equal to Math.random. And then print the value of a every 1 second. Now you will see that every second your a will get assigned a new value. You see, it's printing out a new value of the variable a, and all of these numbers are between 0 and 1. Alright? So see, Math.random helps you generate a random number between 0 and 1. What we have to do is we have to use this Math.random function and figure out how can we generate random numbers that we need. We need the numbers -6, -3, 0, 3 and 6 for the x position of the mole, and we need the numbers 0, 3, -6, -9 and -12 for the z position of our mole. Alright, so let's open up this number line here and let me ask you something. If we tell our computer to generate a random number using the Math.random function, it's giving us a number between 0 and 1, right? So what happens when we multiply any number between 0 and 1 with 10? What will happen? We will end up getting a random number that's between 0 and 10, right? Let's say Math.random is giving you numbers like 0.9, 0.8, 0.75, 0.63. It can give you any number, right? Now when you multiply all of these numbers by 10, what do you get? You get the number 9 for the first one. For the second one, you will get the number 8. For the third one, you will get the number 7.5, right? For this one, you will get the number 6.3. All we are doing is multiplying 10 to any random value that your computer generates between 0 and 1. So if you multiply it by 10, you end up getting random numbers that are between 0 and 10. So now see what's happening. Using the Math.random function, we are able to modify this Math.random to get any random number between 0 and 10. But the only issue now is it's containing decimal numbers that are not whole. They contain decimal points between 1 and 10, 0 and 10. So what we can do now is there is another function in maths called Math.floor. What this does is if you have numbers like 7.68, 5.32, 5.49, let's say 4.56, and let's say we have a number 7.02. So what Math.floor does is whenever it sees any decimal numbers like this, it's going to remove all the values after the decimal points. It just drops it and it outputs the number before the decimal point. So 7.68, if you put that in Math.floor, you will get the output as 7. 5.32 will give you the output 5. 5.49 will give you the output 5. And similarly, this will give you the output 4. This will give you the output 7. So now see, whenever you have any value like 7.1, 7.2, 7.3, if you put any of these numbers inside Math.floor, your output will always be 7. See that? And then if you get any number between 5 and 6, any decimal number between 5 and 6, and you put that between Math.floor, you will get the number 5, just like that. Yeah? So what's happening is, we can use Math.floor in combination with Math.random to generate just integer numbers that we want randomly. Alright, so let me show you here. Let's say we are saying Math.random. Let's say a variable a is equal to Math.random multiplied by 5. So now A is going to be a random number between 0 and 5. It will be a random number that's greater than or equal to 0, and that number will always be less than 5. Now if you say math.floor of this variable A, what this will output is just integers that are either 0. So if you get any random number between 0 and 5 and then tell your computer to remove all the decimal points, right? So if the number is between 0 and 1, you get the integer 0. If the number is between 1 and 2 and you drop any decimal point, then you get the just number 1. Between 2 and 3, you will get the number 2, right? So if you are generating random numbers between 0 and 5 and putting that to math.floor, you get numbers 0, 1, 2, 3, and 4. Only these numbers. So see, we were able to use the math.floor function and math.random functions together to generate random numbers that are completely integers. Now, how are these useful to us? Let's look at the numbers that we need actually. So we need the x position of our mole to be -6, -3, 0, 6, and 3, right? So let me write it down here like this. So our x position of the mole needs to be either -6, -3, 0, 3, or 6. Yeah? Now I can rewrite these numbers. We need to find out a pattern in these numbers. So I can rewrite all of these numbers like this. I can say -6 is equal to -6 plus 0. Then -3 is equal to -6 plus 3. 0 is equal to -6 plus 6. 3 is equal to -6 plus 9. And 6 is equal to -6 plus 12. Now why am I doing this? Now see, we have a common number -6. This -6 is the starting position of the very first box's x value. Alright, so that's why I'm keeping -6 here. And then you see all of these values are just increasing by 3. That's because the distance between all the boxes are 3. So now I can rewrite this as -6 plus 0 multiplied by 3. I can say this number is -6 plus 1 multiplied by 3. This is equal to -6 plus 2 multiplied by 3. See? We are getting a pattern between the x values that we need to generate. -6 plus 9 is 3 multiplied by 3, and then 12 is 4 multiplied by 3. So see, if we want to move our mole to a random x position that only contain these values, then all we have to do is, as long as we are able to tell our computer to generate random numbers that are 0, 1, 2, 3, or 4, right? And then put that random number in this equation, -6 plus a variable a multiplied by 3. And if a is a random number that's 0, 1, 2, 3, or 4, then you get your desired x values. You get the x position to be either -6, -3, 0, 3, or 6. And we already know how to get these random numbers using math.floor and math.random. So using math.floor and math.random, we can generate random numbers that are either 0, 1, 2, 3, or 4. And if we put that random number in this equation, then we will get numbers that are only these values, and then set the x position of our mole to any one of these numbers. And then similarly, if you look at the z position, we need the z position of our moles to be 0, -3, -6, -9, or -12. And all of these can be written as 0 plus 0 plus 0 multiplied by 3. 0 plus 1 multiplied by minus 3. This minus 6 is 0 plus 2 multiplied by minus 3. And 9 is 0 plus 3 multiplied by minus 3. 12 is 0 plus 4 multiplied by minus 3. Now see, again, as long as we are able to generate numbers, the random numbers that have the value 0, 1, 2, 3 or 4, and we put them in this equation 0 plus, let's say, another random number b multiplied by minus 3, we will be able to set the z position of our mole to any one of these values randomly. Alright, so we are going to use two numbers. We are going to use one random number to set the z position randomly, and we are going to use another random number to set the x position of our mole randomly. And see, all we are doing is this minus 6, 3, 0 and minus 3 that you're seeing here. These are just the starting values and the distances from the first box. The starting x and the z position of the first box is minus 6 and 0. And the distances between each of those boxes are 3 units. Now 3 units in the x is the positive 3, and because the boxes are going farther behind, the distances have to be multiplied by minus 3 and not 3, because going farther behind reduces the z value. So let's do this in our code now. So what we will do is, let me go back to my code window, and I'm going to delete all of this code that I wrote here. And we are going to start by first creating two variables. Let a is equal to Math.random. And then similarly, let b is equal to Math.random. Now, this is going to give us a and b that's between 0 and 1. What we need is a and b's value to be between 0 and 5. So a needs to be equal to Math.random multiplied by 5, a random number between 0 and 5. And then similarly, b should be equal to same, Math.random multiplied by 5. So now we have a and b as two numbers that are between 0 and 5. But now a and b also are decimal numbers. We need to drop the decimal values. So we will say a is equal to math.floor of the number a itself. So whatever, like if a is 5.7, then drop the 0.7 and just give the variable a the value 5, like that. So 4.7 will become 4, 3.2 will become 3, like that. And then say b is equal to math.floor as well. Math.floor of what? Of the value b itself. So now we have a is equal to some number between 0, 1, 2, 3 or 4. And similarly, b is also some number that's 0, 1, 2, 3 and 4. Now what we can do is we can click on our Diglett object and say Diglett.setX. Set x to what? To a random number that's what? That's minus 6 plus a multiplied by 3. That's what we wrote in our whiteboard as well. This was the equation. Find out a random number that's 0, 1, 2, 3 or 4 and put that random number in this equation to set the x position of our mole randomly to the values that we need. And then similarly, we say Diglett.set z to 0 plus b multiplied by minus 3. Yep. And this will give us the desired b values. Now 0 plus something, I can remove the 0 from here and just say minus 3 multiplied by b. Now let's click on the run script and see what happens. So see, as I ran the script, my mole moved over to a different box. If I run the script again, it will appear over a different box. So if I keep running the script again and again, my mole will keep on moving over any one of these boxes randomly. So now what we want to do is, we want the mole to continuously move again and again to random positions. So we are going to use our timer function to do that, and we will add a timer. So go to timers, click on create timer, and here, see, inside my timer, all we have to do is we have to just copy this entire code and paste it inside our timer. Why we are pasting the entire code? Because we want A and B to be new random values so that the mole is able to move to new position every 1 second here. Now because A and B are already declared on the top, so I can remove the let from the timer like this. And what I can do is, we don't need to do these calculations outside of the timer anymore, so I can just remove these equations from here. And in fact, I can even tell my computer to just start calculating the value of A and B only once the timer starts. So I'm just going to remove these values from here as well. So see, on the top, we are just declaring that A and B are two variables, and then immediately the timer will start running and A and B will get random values, and then the diglet will move to those random values. So let's run the script and see what happens. Perfect. So now see, every 1 second, the diglet is moving over these boxes. It's moving exactly over these boxes, right? We are not changing the Y position of the diglet, because the Y position of the diglet will make the diglet move up or down, not front or back or left or right. So because we don't want the diglet to move up or down, that's why we are not setting the Y position to any value. Cool. So I think we can end this video here, and in the next part, we will learn how to add the click functionality and how to add the sound effect and the variable for score. Cool. See you guys in the next lesson. Bye-bye.